So let's go. So today we're covering open. So I will explain what we are doing till several classes. This class we cover complex motion, its Coriolis acceleration. Next class we cover again spherical motion. In this case, we will explain the common approach when you used in previous class or home task, for instance, but we try to apply Euler angles and some fancy stuff in it because on a lecture you heard about Euler angles and blah blah blah, but we didn't use it before, and actually it's not commonly used in theoretical mechanics. So I have a goal to.
It's not widely used.
In theoretical mechanics, no. In robotics, in the next semester, yes, you will use it.
Next block.
On next block, yes. In this block, no. And actually, when, for instance, she studied, we didn't cover this too. So it will be a new topic for you. After this, next week, we start statics. Probably 1 or 2 classes. After this, we will have a midterm.
But in this case, we will be late by 2 lectures, right?
What again?
The lab will be late 2 lectures.
Yes.
Because we already discussed.
Yeah. It's no. I don't see any problems with it because actually you have time to read material. As Dani mentioned that it's not so nice when the lecture and the class is the same. Okay. So I didn't receive any questions from the class previous time.
No questions?
What?
I asked you
I asked you also.
12.
Word 12. You asked me yes, but but I answered on it. Okay, sorry. I thought this was some kind of flat. Okay.
Okay.
Okay, we can cover it a bit later. Okay, I will open the Telegram chat and we will discuss. Okay, but so I checked your previous quiz and it was very bad. Actually, only, if not mistaken, Dania find the C correctly, and probably someone else. So it was very bad, and I decided, okay, let's cover this topic. I mean, velocities, accelerations again, and I will explain it. So please use your QR code, open it, and you have 3 minutes to skim the material. Looks really weird.
You did it.
The link is for Stanford course.
Stanford course, and we should
Okay, I
study 16 lectures.
Okay, guys, about this, you will have. Okay. Okay, what about? Wait a second. Okay, let's try this. Okay, I put the correct link.
But the code is good actually.
Yes. Okay. Shit happens.
So this is for also theoretical mechanics, this course?
Yes.
Okay.
It's not for theoretical mechanics about Euler angles. Okay, so no, it's shit. Okay, I'll just send the link. Telegram. Pams. Okay. Can you open it?
I can open it, but I can't see. I can't read it.
Just
High
upload it.
level algorithm.
Just upload it.
That was the key.
It contains a lot of viruses for you. So now I can buy everything. Using your credit card.
But cancer.
I forgot that I have on the 12K stipend.
You know this meme with like Mr. Robot, like Hacker Man?
Yes.
Your best should be on it.
It's social engineering,
Yeah.
I just put the link to the class.
trap my students and take their money.
Yeah. Did you open? In. It's useless. No response.
Use my laptop.
I think it is better like you open it and explain it.
No. First of all, you need to get what's going on there. After
I
that,
can't get what's going on because I can't read this.
Why?
Because
Dani, what the problem?
you're writing.
It's not that bad actually.
Ну как я это читать могу? Я ничего не понимаю, что это. Start to write.
Ну, дальше. Давай, ты уже молодец.
Punctuation from.
Что вот это идем построить тогда?
Actuator. Solve them.
Отлично, ты
Вот это.
As I told you on the previous, on the next week, we will have a LaTeX version of it.
What?
So I asked secretary of my supervisor to make this handwriting into LaTeX. To rewrite.
That's a pain.
And she agreed.
Yes,
Why would she agree on that?
because it's her job.
Ah, okay.
Actually, I don't think so.
Secretary is quite broad job.
Yeah, but not for you.
Ah, yeah.
It's
For you,
it's supervisors, yes, and he agreed because he made this class. These lectures. So okay.
Using IC hints, we know what we need to know. Sounds philosophical.
Read this one, and you will get. If you can do better, you can go there and solve this task. And not receive 05, if I'm not mistaken, from this task.
Actually, it depends on you. How you interpret my genius.
Genius.
Double quotations.
So, I see, as I told you before, that it's not very, probably you cannot code it. It's not so effective. You can code it, but it's not,
All work tasks requires coding.
you can use analytical approach instead of it.
Well, I found the intersection of coding.
It's up to you.
Now take a derivative of intersection, please, and draw a vector. I'd like to see how you can manage it. In which time?
Okay, I
Plus
will.
one.
I will show how this.
Yeah, your math.
Actually, you have
your
quiz on it.
works.
You have quiz, and you need. I will get how you solve it because today on quiz you will have a similar task. About okay, so let's see. So first of all, you need to get that as I wrote that IC we found it for the link, not for the mechanism. And for instance, we have some kind of this kind of mechanism. Yes, it have 2 degrees of freedom. You could, but also you have 2 IC there, because this make rotational movement, this also rotational movement. This is plane and this is plane. So each of them will have IC. And solving this task using IC is not so trivial. But when you have a very pure task like this, I mean simple task, you can use IC. When you I see. Okay. So, what was the first step from the?
Start to write equations.
I mean, not in high level. I mean, when I the solution.
Velocities which you know.
Okay. So in this case, as we get, we can solve most of the we can find most of the velocities if we have angular velocity, actually most of the time. So it's our first goal. We have angular velocity for this link, for this link, but we doesn't have it for this. We need to find it somehow. Also, if we want to use IC in our case, we need to find this point. Okay, we need to find IC for second one. As I wrote it, for finding IC, you need to know the direction, most of the time directions, for 2 points related to this stuff. So this one and this one. We can found it because we know OA, we can found it is VA, and we can found it this one, VD, let's call it D. Most of the times, not this one, because we have the, as you remember, for IC, we need to make it perpendicular to the velocity, and it will be one line. Is the reason why you need to know the amplitude, because of this one. If our velocity will be in this direction, we can also do it, but have another triangle. Okay, we did it. We found this point K. What about D? How can we find it? First of all, we can find it at use VD equal omega 1 R OD. So when you need to find, you just need to get how to take some. You need to try to look on your mechanism different views. I mean, okay, let's find this from this point of view. I mean, when we try to find it from IC, after this from another link is the main intuition. I don't know which I can give you, and of course we can find VD using point A, either VA if we are using analytical approach, or in our case VK equal to 0 plus KD omega 2.
And where is K?
K there.
Ah.
But we don't know this position, and we can find it using the approach from the solution. Actually, you just need to use geometry. When you need to find this, in any cases, when you need to find IC, you use geometry approach. Just cosines and sines most of the time. You don't need to use any intersection parts and so on, just sine cosine. In our case, we have 2 triangles. This one, and what else? And this one.
KD.
This one. And what else? And we can write that
You have R.
VA divided by VD is almost the same that KD is AK. Mistaken, yes, or mistake, yeah, it should be vice versa. It's one equation. We have 2 variables, one equation, and we need to have another equation. It's AK plus KD equal AD, and we know it. So after this, we can find what we needed and put it there. we found V2. After this, we just need to, so in IC, you just need to draw a perpendicular, and it will be your velocity. So in this case, it will be this perpendicular. In this case, when we have B, it will be this perpendicular. That's it. So it's one of the easiest approach to draw it correctly, because many of you in C point draw it like this. It's wrong. So it's perpendicular. I'm not. If you want to know to find complete numbers, open the solution. Just don't forget that how you can find it, because omega cross product R in this case K C. Omega this way, R this way. It should be perpendicular. So the main hint in this case, because your omega rotates like this, so in pseudo vector it should be on us. Just to think in terms of cross product provides you the perpendicular vector to this plane. In this case, you won't forget how to find what you need. And actually, in spherical joint, it helps you a lot too. If you want to find it in terms of not IC, but using other approaches, in this case, you just need to go from A to C. And from A to C, it should be perpendicular. Way AC or CA. C around point A. Okay, and this one looks in this direction, but actually it should be there. So it will be all, I think. We just need to summarize the vectors. So to sum up, in this case, you just need to, yes, don't forget about perpendicular or collinear. When we talk about accelerations, one normal part should be collinear to your length, to your link. And the tangential should be perpendicular. Not perpendicular, tangent to the path, actually perpendicular, yes. That's it. And after this, you just need to summarize vectors. I hope you remember how to do it. When we have two vectors like this, we should draw, it will be our vector. If we have, it should be like this. That's it. It will be on your midterm, of course.
By the way, midterm is gonna be next week, right?
Either next week.
Oh, okay.
If I decide that you're ready,
Okay.
it will be next week.
And
Otherwise,
you said
It will
it's
be
gonna
next.
What? No. If you have one, we can put you. I can provide you one extra week, but not more.
okay. And you said it's gonna be divided into two parts.
It will be one task will be about kinematics or statics, and 3 other tasks will be about kinematics.
Okay. I was asking. You said it's gonna be divided into two parts.
Coding
on paper and coding.
No, it will be on the on handwriting.
Oh,
On final exam will be with coding. This one no.
okay.
Okay, today's quiz. We need to. It's your last quiz about kinematics. Again, the same task.
For all points. Solution. Okay.
Solution, of course, no, solution.
Only solution.
Only solution, yes.
Approach solution.
Yes, because you had near the same home task.
Yeah.
Near the same. So now you may try to solve it. $15 minutes. I think it's more than enough for the start.
So generous.
Tils is working. Mm-hmm. Where it is? Bombs. So Eric, you told me that Jablonski didn't provide any task about kinematics. Open K9. It's called
K9 is K9. You take a task from K4 and say to simulate it. It was never meant to be simulated. That's my point.
okay, but you will
Okay.
practice. Don't forget to highlight the answer. Because remember, you can not obtain some points possibly. minutes left. 10 minutes. Out of 15.
Really.
It doesn't matter in which center, main center. You know ID, C and DE.
Так решительно или алгоритм?
Ну, алгоритм это решение. Ставить цифры это для лохов, это каждый лох может.
Найти производные тоже, да?
Да, ты загоняешь, и он тебе численность считает.
Он не пользуется. Он только точка. Он только точка.
Ну, это для ID,
Вот так нормально или что-то еще надо? Я так уже построил такой программу. Нет, если хочешь проверить твои продукты, скажи, это только все, или мне надо что-то вставить, циферки, функцию от...
Ты можешь показать примеры, что у тебя сколько неизвестно, какие.
Ну, я не стал специальных выбирать, я могу
Подчеркнуть. Guys, it would be nice if you highlight that these variables you don't know, but the six, so for instance you have two equations, two variables, so you can find something. It will be much easier for me to check. Do you get what I'm asking? So you write some equation and highlight, for instance, x, y, x, e, we don't know, and this we know. Because
увеличенных.
Вот сразу видно домашку делать, как приятно проверяет. Давайте.
You forgot to
Вот это не сказал, я
you forgot to farm when I put it in your grade.
I see, yes. Ты какой-то другой сейчас висит, да не почему.
That's 100%.
I think about point C.
Нет, а что ты хотел point C, чтобы типа с треугольника начать?
Ну, просто надо проще. Тебе даже не через треугольник.
Это
Если
если
неизвестный треугольник, тебе известный угол внутри.
неизвестными углы, неизвестны три стороны. Это вообще
Я
как
можно и два.
вокруг этого друга.
Тут нет просто во многих задачах дается потому что он типа статичный. А я же написал все углы, все друзья. А, углы. Не-не-не, я. They just okay, guys, let's answer a bit because 1 minute left. Time is up.
Я берег поймал.
Если нужно что-то поставить. I'm going to Henny. Still so black blood. But you're a cheater, you already have free to be.
You decided to give me the points.
Yes, I know. No worries. 3, 2, 1, go.
Ладно, короче.
Okay.
Why the ползунки?
So,
Кран, короче.
you can solve this task. It was just almost from your home task. First of all, we have this guy. As you remember, intersection between two circles. We found B. A, of course, we can find because we know this angle. Found C, we can find using two approaches, either because we know this triangular and using sine cosine rule as you want, or again intersection between two circles because you know O, A, B, and just 1, 2. Hooray! After this, so it's one Asur group actually. We can decouple and solve this Asur group. Now the second Asur group is this one, and after this final one. Or we can forget about it. Okay, the final. Okay, you see, we know. I mean, all these positions. Now the problem: how we can solve this one? There are two approaches. One of them to find this angle. One of these approaches, and after
You don't know D yet, how
you know, you can think in terms of cosines and sines. One length, second length, third length. You can use sine rule and you find one angle. But for using after this the changing frame rule approach, you need to know this full angle. You can find ACA triangle, and also using sine rule find this angle, small angle. Did you get this angle and this angle? After this, you can find this point using just how to say changing frame rule. Otherwise,
intersection of the circles.
yes. Otherwise, you can find intersection of two circles, one circle and second circle, and this one also circles.
No.
Not in
E.
For E, you
For
should.
yes.
For E, vector.
Yeah, but
Yes. Yeah.
since E lies on CE, so you defines unit vector in z direction and step EC.
Or find angle this angle out of this just makes this one. Because when I thought at whole, I didn't find the approach using vector, I just using two angles. You have many ways to solve the task. Yes, your
I'd
solution.
like to see how it is.
What the problem is that sine rule 1, sine rule 2.
I want to see it's working, coded something. I want to see like the length of formulas you get.
Okay, so that's it.
Can you please just, like, in a very fast way, say how we will solve it, what link by link via like circle methods? Circle method.
Oh, it's fine, I can explain later.
Actually, Daniel is better because he wrote some comments, not just equations. Okay. Nice job, some of you. At least now I know for sure that some of you did home task.
You can check Moodle submissions to check if someone
Okay, so today the topic is Coriolis acceleration. I forgot to put the text, the text there, the text in solution. If not mistaken, we know VE. What else? Could you open it?
That's Stanford.
It's Stanford, да? Not for girls, sorry. Not today.
Matt's hand interrupted, not hand, but hand interrupted, so I cannot like go with again.
Did you open it?
Yeah. Fuck it.
Why?
New handwriting again.
Could you say again what we know and what we don't know? We know M and we know.
You know S of t, alpha equals 60 degrees.
Mm-hmm.
Also C1, whatever it is.
Yes.
And omega
E. Okay.
That's all.
Okay. So the task to find the commonest task, find the velocity and acceleration, full velocity and acceleration for M point. So what the problem? So first of all, we need to get what's going on there. Do you understand how to get when you have Coriolis acceleration and when do you not have acceleration?
Right.
No, it's no. Okay, there are two sides. So two possible understanding. One of them just on fingers in layman terms, and another one using formulas. So when we write equation for point M, it will be AA plus A transpose. Okay. Next week I will have linear algebra. My brain has already started to work on this. Okay. M plus 2 omega E plus what else?
Now this, I don't understand.
Okay.
What? Let me write it before he forgets.
What again? What the problem? I think.
Something.
No, just explain what you've written. That's
Something.
Okay. So in terms of when in layman terms, imagine that you have a bus. not this PCI bus, but I mean common bus, and you on it. So you try to go from one point to another point. So in this case, when you the bus just moving, and you are going somewhere, move forward. You won't receive this guy because it's about transport stuff. It's related to the bus. It's a bus acceleration. This is for you, so it's relative, if I'm not mistaken. And this something between. It's appeared because when you find derivative, you can open the how to obtain this equation. You will get how it's appeared. But in intuition, you may see that it's related to transport one. This related to relative one. If our bus move linearly forward, just forward, you won't obtain this guy because your angular velocity will be equal to 0. So you won't have Coriolis acceleration. And you may imagine when you get when your bus moves, you just feel that acceleration of the bus, but it's not an effect on yourself. You just go and that's it. You can jump. You don't have any problem.
Never tried.
When you go to the bus and try to have a seat, you are moving.
Jump usually when you want to
Okay.
outrace some
Okay.
gradient.
Second one, relative one. It's you in the bus. But when your bus start to rotate, I mean, it should turn right or turn left. In this case, your Coriolis acceleration appeared. So for having a Coriolis acceleration, you need to have both angular velocity from transport part and this one. Mainly you have it because if your point moves, it should be your velocity acceleration. That's it. And it's cross product.
So according to what you're saying, whenever we have angular velocity and
When you move in something else, I mean, you have a board, it moves, and if it rotates, you should have,
Coriolis.
yes, you should have acceleration, yes, a Coriolis acceleration.
Whenever we have rotation, we have Coriolis acceleration.
If you moves, yes.
Yeah.
So when you need to solve task, actually, it's let's call it more. It's advanced task from your previous ones. So now you know kinematics, and you showed it to me, at least some of you. You know how to find velocities and accelerations. Now you just need to do it 2 times. Not really 2 times, but you need to make a, let's call it mind experiment. First of all, we need to find. So you just need to fix the m. And you need to solve tasks as you did it before in our previous classes. So you need to find this one. After this, you need to, and you fix m, I mean, you need to fix m on this plane and you solve it. After this, you fix the whole mechanism. So you fix bus and you just work with your m. After this, you need to combine it. So it's the algorithm. Let's do it. First of all, as I wrote it before, it's a tricky moment because in some cases you have this rule according to the global coordinate in real robotics tasks. And you need to somehow put it in relative. Actually, you cannot do it. There are several approaches. Probably I can send you extra link for this. I just want to highlight this for our task in home tasks. Most of the time you will have in nature way естественные координаты. And in this case you just need to derivative several times and you will obtain your solution. But in the real one, for instance, when we have, for instance, assume that your research task, now your robot move just on the, on the ground. Now let's assume that it move on the board. In this case you will have more difficult task. It will be more difficult task. Actually, probably it will be a home task for the next generation.
Home task, not research task, but home task. That's okay.
1 week, okay. So, I'm not kidding, but okay. So let's find this m because we know this. Start from this and move it, blah 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 blah. Move like this. We know this rule. How can I find it? We know that this point it's t1. So we know some particular time, but we need to find it. Actually, in your home task, you need to simulate it, though. You will have almost the same task. You need to simulate that your t moves, it rotates, and so on. your home task will be provided on Wednesday, but I already prepared it. So we need to find M. First of all, we need to find this particular place. So it will be ST1. Let's put 0.5, and we found something. Okay, we found this point. What else? We can, okay, let's go from the relative part. Probably it will be easier for us. We need to find V. V, M, relative. How we can find it? The S for dt. It will be 12 t squared. And we can find particular one for T1. T1, it will be, it doesn't matter actually, but else we can find it because just need to put T1. Let's drop numbers for now. Okay, we found it. We need to find direction because as you get this equation, sorry. It should be it in vector form. We need to get, so it moves along this line. I think you get it.
Yeah.
We have positive number. We should actually, let's assume it's positive. In this case, our velocity will be there. Are you with me?
Yes.
Image? This way. Where is
So up to now we just took this relative motion of M and differentiated.
Sure.
Let's move on.
Где-то потерялась.
Да нет, я пока воспринимаю все норм.
Okay. So if you didn't get, you can open solutions and read it. Again, we want to find acceleration. Again, AM relative dv for dt. It will be 24t, if not mistaken. After this, put again, and we found a m t1 per. How should it move? It's positive because t is positive. In this case, we will have a also there. Hooray, we found this part.
Okay.
Nice. So we found, we solved half of the task. After this, we need to solve second part of the task, transport part. If I were you, this task is much better. Now it looks probably kind of difficult, as for me. I rewrite it in top-down view. So we have point this one, A, we have C, and we have M. It's just one link. We solve it a lot of times. Of course, in this case, we can easily find V and so on. We know V E, and our velocity for this guy will be something. I think you get that we need to use this one. Either is in top view, so we make a projection, and this R can be found because we know this guy and we know S. It will be S cosine alpha. Oh, sine doesn't matter actually. You can find it. Actually, boom, it will be there. And yeah.
It's going to be cosine.
Yeah, cosine. I'm right. After this, we need to find A. We have rotational, only rotational. So it will be normal. Actually, we need to draw. So it will be V M transport.
It's going to be towards A.
And we need to find M. We have only normal part. So
P squared over O.
yeah. again this R. How, so again, the omega there, rotation there, and
Towards A.
okay, we found A, we found this A, and we found this one. We need to find this one after this, combine it together. Okay, omega E, we need to understand firstly, where it's easier to draw. Actually, as for me, it's easier to draw on this picture. Yes, it's about projections, and we cannot draw it correctly, but we need to understand how it should be because of vector form. We need to calculate it soon. We have V this way, and omega this way, or there. Our should be like this. It will be VR, VM, R, and this one, this. It will be arrows, Да.
Why?
Because you have one, see, in this case, we have one and one. It should be perpendicular, so it will be this one, it will be the, yes, it is boom. Did you
This
get?
is what? This is omega.
It's this omega, this one is V.
V. So this is for
It's one on the plane, yes.
Ah.
And perpendicular to
Yes,
this,
yes, yes.
it will be Coriolis, A Coriolis.
Mm.
Did you get any?
Right-hand rule.
Actually, right-hand rule, Malaretov dislikes this rule because he thought that it,
He's left side.
no, I'm also left side. The problem is that I'm left-hander, and so he joked. No, he's providing another rule. Actually, it's, I will write it because I will write it later because even me didn't get. It's more intuitive. So from your first vector, second vector, you should move counterclockwise. In this case, your vector will be positive.
Like a screw.
Screw. Yes, but actually he doesn't use any fingers.
Like, no.
He just say it by board. I will write it. Actually, it's, in this case you won't have any mistake because your right rule, left hand rule, left finger on your foot rule.
Yeah, go on.
There are a lot of rules, but it's some cases more intuitive. But in you, for instance, where is your A? Where is your B here?
I don't know what is B.
So in this case, you may forget about it, and
Okay, from A you rotate to B, and this finger.
that there are a lot of ways how to represent this way. I will write it when Himlatov says it again. I will write word by word and provide it to you. Okay, because I also have some mistakes with this one. Okay, we found, yes.
By the way, out of topic, what if we want to attend Klimchik's
Yes, and Henny too. We should go. So I tell to organizer that we will do after the class. We will go to garage. Okay. Because I should present, should be as a program manager also be there. But the education is more important than the shitty part. Okay. So next stuff is we need to combine it somehow. In vector form, nice. We need to present it x, y, and z axis. X, y, z. Let's go. A M X, A M Y, A M Z. So what do we have? We see that X only this guy. Coriolis. A4. Do you agree? Because only this guy looks on us.
Yeah.
Okay, what else? We have M. It should be there. It's on y direction. Minus A M transport plus. And this guy have cosine and sine. But not 60, but 30, because we need to take not this angle but this angle. Plus a inverted probably cosine 90 minus alpha. Or sine does actually you can do it at home, doesn't matter.
Like here you project, here's your out 30 degrees, and after this will be sine.
Ah, sine things. And also there will be IM relative cosine. I solved correctly at home. Now I'm just. That's it. You found it. For A. We found A and we have V. And V. Of course, we need to summarize it. We found V there. In this direction, it's our VM transpose, and it will be there. Transpose. Sorry, when I wrote like T, it looks like transpose.
It's right, like the capital T for transpose and little t for T.
And in this case, we just need to. It will be 90 degrees in our case. Because this one and this one 90 degrees.
You found the magnitude,
Yes, for VM.
but for acceleration you found the here just like
Again, I didn't get the question.
vector, how vector of full velocity will look by component.
We find relative one. So
I thought you were right.
we found for
Just
only
like
for
you
relative one,
said.
and we found for for transport one.
It will be magnitude. Like, can you get the vector of 3D velocity, complete vector?
In our case, we just need to.
Just so the S, X.
It will in vector form. It will be how to say no. You need to solve it in vector form. But in our case, it will be 90 degrees. Okay. Where is VM? This one. How it will be? What it is? We transpose in their way, and it won't 30 degrees. And you just need to solve it. That's it. It will be like this, boom. Because it rotates.
Will be two components, right?
If you can find more components. Okay.
That's that.
So, do I need to? So we have two people who probably didn't get it.
I understood.
So explain me how to solve this task again.
Uh,
Step by step.
Step by step.
Yes.
So first of all, as I understood that we should first find relational acceleration.
Actually, it doesn't matter. First of all, we need to find the position of m, because otherwise we cannot solve the task. After this, you can return to the either, transport part, or continue to solve velocity relative part. It's up to you.
Yeah. So first of all, we find equation for coordinates. Then, as not coordinates but trajectory.
It was provided.
Yeah. Okay. Then we differentiate it, and then
Could we find using another approach? Not differentiate this guy, but probably make it in coordinate form after this find derivative.
I think it's going to be hard.
Can we do it now?
I think
Okay, Danya, what do you think?
How to solve it?
Can we transform this to coordinate form and after this find derivative?
Of course. You make
It's useless for this task, but
you
yes.
make unit vector AC. So you find the directions. Since we know position of A and position of C. After this,
you move along the line HC, starting from A, by the magnitude of S. So
You can do yes. Actually, it's your research home task because you need to do you need to go from the path form to the Descartes form. I mean
not the big
Cartesian
homework.
to Cartesian. Not
For big homework, that's
yes. I mean the idea is the same. At least, did you try to solve the big homework? Okay, only Dani solved it. Okay. So let's continue. You didn't finish.
Yeah, and now I lost because as far as I know, we have relation part and yeah, transfer part. So we have derivatives for coordinates.
Okay, you found derivative for n found v. After this, how do you find acceleration
Acceleration
relative to acceleration?
Yeah, so relative acceleration we find. Okay, I'm lost.
Okay, you find again a derivative for the velocity. About directions, you can, in this case, you just need to think how it moves, and after this, you will draw directions. It's the easiest way. Of course, you can do it using another approach, using math and thinking. Even you can transport it in Cartesian space, and after this, work with it. But the easiest way, just yes. So okay, we move along the line. We have all positives, so it should move with acceleration. It's the easiest way. After this, again, we need to solve the common task with rotational drawing. We just have one link and we need to find velocity acceleration for this guy. I redraw it because in this case it's look like a really easy task. When you look on this as it is, it looks more complicated as for me. When you look at this, you see one link joint, one link, let's say, mechanism, and you just solve it in one click. And as this, you need to combine it together. And don't forget about Coriolis acceleration because you need to find it correctly. The direction. Actually, we have solution thanks to Henny because you told me to write the solutions. Actually, I spent 1 hour for each sheet. For each task.
you see, and after this you need to plot this.
You need to code it.
Yeah.
And you realize that your solution is not codable. Oh shit!
No, it's codable.
No, I mean, that's how much we spent.
Actually, it's your task. You need to solve it now. But before, because probably won't have time, I want to comment about last lecture. Lecture from the Poletin lecture, because he provides a lot of material, and it seems for you like okay, and why do we read it? Okay, I want to comment on that. Okay, so there is blah blah blah. We don't need it. Don't need it. Blah 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 blah. Actually, these equations. Actually, some very smart guy just found this solution, and you don't give a mess about it, just to use it, no more. You don't need to know how to find it. If you need to find screw motion, just Google it. Okay, after this we have this one, Euler angles, blah blah blah, Cardan. Actually, do you know why do you know the difference between them? Not only about order. Why did they appear? Why we have so many?
Singularity, because of singularity.
Okay, but why do we need to have Cardan or ship? Also, it's also called ship angles. Also, we have. Any suggestions? Yes.
They needed to make this table fixed when both rotates, so they introduced this coordinate frame, and that's why it rotates like.
Did he explain actually this one? Why is this?
About the shape.
So actually, yes, it's appeared because of singularities. We have plane, we have ship, we have some other transports, and we know their motion. So Yes, we have singularities. So they decided, okay, let's assume that it will be our angles, because in this case, most of the time we won't receive singularities. Because we choose one angle of motion. In this case, our ship can move like this, like this. They won't have a big angles on this place. It's the reason why we will have ship angles. On a plane, the same. We cannot rotate like this and so on. So it appeared a lot of type of angles, names of these angles. Actually, the idea beside them, the equal idea, is because of let's make these angles because we want to avoid singularity as much as possible. That's it. But we have one friend called quaternions. But I think he put it in wrong way as for me. Because first of all he put some shit about Euler angles. And after this he put quaternions. Actually, do you know why do you need this one?
Because it's similar, like to quaternion somehow.
Actually,
Or this is the type of.
this your friend. This equation is your friend. Why? When you have quaternions, probably I explain it in your linear algebra. You cannot imagine it. Yes, you can open Code Blue Brown, Triple Brown, yes, and watch this strange video about superplanes and blah blah blah. But it's not intuitive for you to get when you see these quaternions. You cannot understand what the real angle is.
Because you will be different.
Oh shit.
Yes. Do you remember what the benefits of quaternions? It doesn't have any singularities.
And easy to manipulate.
So on all on all computers now in game dev, in ROS, in robotics, most of the times use quaternions. But you won't get how it should look like. In this case, you use this equation, and you will get rotation matrix. And using Euler angles or whatever, you can receive the precise angles for your robot. So it's common practice to write code. So you wrote the quaternions, but if you want to represent it to you, you just make it into rotation matrices. You check how it looks like, and after this, go again. So the main goal of this slides is for me to represent you. Yes, we have quaternions, but you cannot use it in direct form. But you can use this guy. You can understand how to work with it. After this, you again return to the quaternion. That's it. It's my comment about this topic. But now let's go to the about home task. After this, go to the your home task is read about Euler and fixed angles and understand what's going on, how it works. So this Hangouts and lecture is from Khatib. It's a guy from Stanford. My introduction to robotics was actually his course because I didn't have one in my master's degree. Shit happens, yes. So I really appreciate these classes. Actually, it might help you too when your next block.
You know he's Syrian?
Yeah.
Yes, I know. And he really likes to drink vodka, and not only. Because Igor Gaponov and Klinchik saw him a lot of times. Yes. Okay. So the task on your.
Now.
Yeah, now you have. Oh, actually, we. No. Okay. You need to practice.
Yeah, I know.
Will you solve this test at home?
This?
Yes.
We may.
Yeah.
Okay.
But we better.
Let's solve it. Okay. If you were Henny and Ahmed wants to finish earlier. In this case, you need to explain me the algorithm how you will solve it.
I'm listening.
I'm just trying to figure out.
Actually, if you can say me the algorithm in this case, I'm sure that you can solve it. 70%. The remote book. Have you seen it in the real life?
No.
Oh, we have 3 of them in the lab. It's really heavy. You can kill some people with these books.
Sebastian knows shit. Sebastian somehow.
What are you talking about?
Yes, it's very heavy book in both meanings. So, Penny, each minute when you speak, we calculate.
Я очень сильно думаю, но там ничего не работает. Да, я домашний.
Make it strong, both strong.
Я очень
Like
хочу увидеть,
boys.
как Олег аналитик, он это все решает и кодит, короче, получает картинку за час. Я хочу на это посмотреть.
Так у вас 8 часов в неделю, ой, 16 часов в неделю должно быть.
24 часа в день.
Давай,
Хоть
думай.
25.
Не, серьезно, уже 16 часов в неделю должно ходить.
Я, по-моему, их раньше первые 3 дня.
Мама кончает. Придется денег.
So maybe we have like the three components: Coriolis and transport and relative. So A is the relative to C is omega multiplied with R, and the transport we need tangential and we need the normal. Normal, and we need the acceleration of C, which is the acceleration of whole car, so AO, plus tangential for C. So we can, in that moment, we can calculate the velocity and derivative. For the velocity would be the tangential, and for the normal would be epsilon multiplied with R. With not R, but with
So do we have Coriolis acceleration there?
yes.
Why?
No. See, the main problem that
But the car is moving, and there is some.
you need to imagine this task in different manner. In this case, you will solve task in 1
I
minute.
mean, this stuff, like.
You don't need to think that
You
it's
fix
so.
the coordinate frame and forget about acceleration.
Yes, but you have like moving part, and there is another moving part. So the main frame, the reference frame, the original frame is O, and the car frame is, for example, on C, and the frame.
Does your car rotate?
Car is not rotating.
So in this case, we don't have omega and we
But
don't
the
have
reference-
Coriolis. No.
Okay, so it depends. So
You think-
so Coriolis, when the like big object frame is rotating.
Yes, I explained. We have a bus and we have point U on the bus.
Олег.
Bus rotates, you have Coriolis.
But we have omega of motor. And it's
You
perpendicular
need
to
to think.
velocity.
It's a bit tricky. It's a bit tricky task, actually, guys. You're trying to think that we have different motor and blah blah blah. Try to imagine our task. We have a big block, and we have A. We in this task they provide the S. I mean the path. In this case, they just provide it in coordinate frame. I mean we have velocities, velocities, and this one. But actually, all this circle, we can call it as a path, as the rule of for our A. So this circle is our relative part, and you need to solve it aside of the acceleration. So it's just one link rotational part. You need to solve it using analytical approach, for instance. You just fix you forget about this A and solve the circle. You have A, omega, and you solve it. You found everything. A, velocity for this guy. Don't forget it because of you have epsilon, you have tangential acceleration, and in this case your acceleration will be not norm, not centered. When you watch to the center, the final acceleration will be somewhere else, like this problem.
But we don't have epsilon, so how can
No, we have. So there's value for tangential.
You can find derivative. Yes. Hooray, we solved this one. After this, they already found transport part for you. It's already a solution. And you don't have a Coriolis because it doesn't rotate anywhere. And just need to find the vector.
So the Coriolis happens when the frame of the body
Yes.
is rotating around the reference frame, the world frame.
You try to. Yes. Okay. In this case, yes.
Okay, so if we have a robot and this is just only translation motion, and this robot has
If you
like,
have
for
on
example,
translation motion, you don't have Coriolis acceleration.
Okay, for example, we have like mobile robot, and this has like inverse like pendulum. Okay, so in that moment, and this is only translation motion. So
Yes.
we don't have Coriolis.
No.
Okay.
You may write equations and get. So I hope you will solve this task at home, because you need to finalize your knowledge now. We discussed about algorithm, how to solve it. At home, you need to get how to work with it. Very nice mouse.
You promised any comments about home task?
Home task.
Please say what we don't need to know the list.
Do you know that representative can use some, I don't know, forbidden word, not forbidden words, taboo, I forgot how to do it.
And worse.
He can say that no more questions as a representative, yes? Henny?
No, why?
He will stand with the people. He's not a dictator.
Yeah, I'm
Oh.
not like you.
Yes, I'm dictator, and I'm proud of it.
Good for you.
I don't see any problems to be a dictator.